Okay, so let us start with the chapter random variable and distribution. And now before I start with random variable, first of all let us know what is the variable. When we speak about, say, height of a person, the height is treated as a variable. When we speak about the temperature of a day, then the temperature is treated as a variable. When we speak about the amount of, say, rainfall in a particular week, then the amount of rainfall is also a variable. Marks obtained by a student in a particular exam paper, this is also a variable. So what is variable? So variable simply is a phenomenon which can take different values. A variable is a phenomenon which can take different values. Now height of a person can take different values, say 30 centimeter, 35 centimeter, 40.2 centimeter, like that. It can take different values. It's a variable. Weight of a person is also a variable. Temperature of a day, the temperature of a day can be, say, minus 10 degrees Celsius, say 20 degrees Celsius, 40 degrees Celsius. So temperature is also a variable. So variable is a phenomenon which can take different values. Now let us explain, let us know what is this random variable. Now random variable is a variable which can take different values with some probabilities, and if the sum of the probabilities is 1, then that variable is called a random variable. A random variable is a variable which can take different values with some probabilities, and if the sum of all the probabilities is 1, then we say that the variable is a random variable. Now let me give one example of random variable. When we throw a dice, then the number turns up. This is a random variable. Why? Because the number turns up, this can take different values, 1, 2, 3, 4, 5, 6. Fine. Now what is probability x equals to 1? This is 1 upon 6. Probability x equals to 2. This is also 1 upon 6. In this way, probability x equals to 6. This is also 1 upon 6. Now you see, if we sum up these probabilities, we get the value 1. So this is a random variable. So a variable which can take different values with some preassigned probabilities, and if the sum of all the probabilities is 1, then the variable is called the random variable. Different other definitions are there. So for you right now, just to know this one, this much concept is enough. Now two types of random variables are there. One is discrete random variable, and another one is continuous random variable. You see, discrete random variable means a random variable which can take some selected values. A random variable which can take some selected values. For example, the number of telephone calls received by you in a particular day. This is a variable, but this is discrete. Why discrete? It cannot take number of telephone calls received. It cannot take any possible value. It can take only some selected values like 0, 1, 2, 3, 4, 5. This is a discrete random variable. Number of accidents in a city in a particular year. This is also an example of discrete random variable. On the other hand, what is continuous random variable? Continuous random variable is a random variable which can take any possible value, within some limits. For example, the temperature of a day. Now, temperature of a day can be, say, minus 20 degree to 50 degrees Celsius. Now, within this range, the temperature can take any possible value. So, this is an example of continuous random variable. Now, weight of a person. Weight of a person can be, say, 60.2. It can be 70. It can be 69.01 also in kilogram. So weight is a continuous random variable. Height similarly, is a continuous random variable. So this is the difference between discrete random variable and continuous random variable. Now see the probability distribution and function. So first of all, let us know what is this probability distribution. Probability distribution means the distribution of probabilities for different values of a variable. Now here x is a random variable taking the values x1, x2 in this way xn. So definitely x is a discrete random variable because selected values are there. Now for each of these values the probabilities are given. For x, when x takes the value x1, the probability is p1, x takes the value p2, probability is p2. In this way, when x takes the value xn, probability is pn. So this is the arrangement or the distribution of probabilities for different values of the variable. And now this is an example of probability distribution. But some criteria is there, and the criteria is that this distribution is called the probability distribution only if the sum of the probabilities equals to 1. That means p1 plus p2 up to pn equals to 1. Now in probability distribution, actually two types of probability distribution are there. One is discrete probability distribution and another one is continuous probability distribution. Now you see, let us tell you one more thing. If I write x is a random variable, one thing you notice here, you see, whenever I say a random variable, I use the capital letter. You can use another letter also, y, z, anything, but by convention, when we speak about the random variable, we use the capital letter. And these small letters, x1, x2, xn, these small letters are used to denote the particular value of a variable. Now, similarly, if I write capital X1, in general that represents a variable, and when we write small x1, in general that represents the particular value taken by the variable. This is by convention, there is no hard and fast rule, but in general we follow this. Now see, the probability that a random variable takes a particular value, the probability that a random variable takes a particular value is called the probability function. Is called the probability function. So simply, if I write probability x equals to small x, this is a probability function. Now, if x is a discrete random variable, then the probability function is called the probability mass function, and if x is a continuous random variable, then the probability function is called the probability density function. I will come up again with this concept. So let us first of all know what is this probability mass function. So basically, what is probability mass function? In short form, we say that this is a PMF. So PMF is the probability function of a discrete random variable. And how we define the function Px? You see here P small x. It represents that the concerned variable takes the particular value small x. These are symbols. The function Px or probability x equals to small x is called the probability mass function of the random variable x if two conditions are satisfied. What are these two conditions? First one is Px greater than equal to 0 for all x. That means whatever value x takes, all the probabilities should be greater than equal to 0. And the second criteria, this is very important, that sum of the probabilities should be equal to 1. So if these two conditions are satisfied, then the function Px equals to probability x equals to small x is called the probability mass function. Now see, we want to verify whether this distribution is a probability distribution or not. Or in other way, we want to verify whether this distribution is a PMF or not. Now, what are the criteria for the PMF? As I said, all the probabilities should be greater than equal to 0. Now here you see all the probabilities are greater than equal to 0. So first criteria fulfills. So next one, we see the sum of the probabilities, whether the sum is equals to 1 or not. Now summation probability x equals to small x, and writing here x means sum of over all possible values of x. We can write in this way also. Summation probability x equals to small x, x goes from 0 to 3. But in general what happens, we write this way. Why? Because summation x equals to 0 to 3, it means that x equals to 0 plus x equals to 1 plus x equals to 2 in this way. But sometimes it happens that the possible values of x are say 0, then 2, then 4, then 6. In that case, if we write summation x equals to 0 to 3, it gives some, what should I say, not clear idea. So the best thing is that you just write summation probability x equals to small x and sum over all possible values of x. It reveals that sum over all possible values of x, and here the all possible values of x means 0, 1, 2, 3. So it means that this is probability x equals to 0 plus probability x equals to 1 plus 2 plus 3, and if we sum up all these probabilities we get the value 1, hence verified. That means the given function or the given distribution is a probability distribution or a PMF. PMF means probability mass function. Now you see the same question I put in different way. For what value of A, the following is a probability distribution. For what value of A? That means if this distribution is to be a probability distribution, then we must have sum of the probabilities equals to 1. So we sum up all this equals to 1. So this is the condition, and from this condition we get the value A. So for A equals to 3 by 10, the distribution becomes a probability distribution or a probability mass function, you can say.